Hey everyone, this video is going to be on MA162 Exam 1 for Spring 2019. And since there is the solution page uploaded to the PAX exam website, I'm just going to use that as a guide and further explain some of these solutions. It might not be explained well like this one, they give no explanation. So, let's start question 1. It's a classic. Find the with a sphere equation, find a variable stuff, find the radius. So for these type of questions, generally you want to complete the squares, get to something that looks like x minus x0 being the x-intercept squared plus y minus y0 plus z minus z0 equal to the radius squared, and then you can get useful information out of that. So for here, as we can see from the solution, that first it combined the x terms and completed the square with +1 and +1 on the other side, and did the same thing for y and z here. So +4 and +9, just simply completed squares, and then simplifying, combining all the stuff, we get that the sphere is would be located around, that would be -1, 2, and -3, with the radius here. No, I mean the radius is here, and then the radius would be 2 squared as it's r squared over on the other side. So since the radius 2, c plus 14 is 4, therefore c is -10 with option E here. Moving on to number 2. We are given two vectors and find the projection of one onto another. So the general formula is here. This is one of the formulas you want to memorize. So the projection of W onto V would be W dot V over the length of V squared usually. So you can combine these two and then times V. And so here is just trying to create that. So on top would be W dot V, and that will equal to 14. And the length of V is calculated here, 7 squared, and that will times the length of the actual vector of V, and cancel 7 out of the top and bottom. So we get 2 over 7 times V, and that would be 4 over 7, 6 over 7, and 12 over 7, which is option D here. Right, moving on to number 3. Which the following statements are true? So if for number 1, if you are trying to find if the vectors are orthogonal, generally you can either cross product it or do dot product, and I would recommend doing the cross product since cross product is the length of cross product is the length. Let's say the vectors are u and v. It would be the length times sine. Oh, wait, cosine, right? Yeah, I'm sorry. It should be cosine. Hold up. Right. So actually, it would be better to do dot product. So in here, I would try to um, dot the two vectors together, because if they're orthogonal, then the length would equal to it just equal to the two vectors times the cosine of the angle in between, and if the angle in between is a 90-degree, then that will make a 0 and the whole thing 0. So with that in mind, let's complete the dot product, and we'll notice that the first vector is actually 2i plus 0j plus 0k, and the second vector is 0i plus j plus k. All those should have the little hat, but that's fine. And then the dot product would result in 0 plus 0 plus 0, which equals 0, confirming that it is an orthogonal. They are orthogonal to each other. So number 1 is true. Number 2, if v is a vector in 3 dimensions, then v cross v equals 0. So for these questions, you can generally just set an arbitrary value of, let's say, v has d vector a, b, and c. And so when you cross them, say a, b, and c, then the first would be bc minus bc, and the second would be the negative of ac minus ac, and the third would be ab minus ab, which would result in 0. So that it is true that if you cross the same product, the same vector to itself, it will be 0. It doesn't matter if one of the value is 0 or infinite, it should always be this. So number 2 is also true. And for number 3, if w is a vector, then w dot w should be the length of w. And in the same way, we can say that w has the values of a, b, and c. And when we dot them, a, b, and c, it would equal to a squared plus b squared plus c squared. And we can see if that equals to w, the length of w. So the length of w would be the square root of a squared plus b squared plus c squared. So for these two, they're clearly not the same, but if you square this, then it will be the same. So it's actually identity, I think. If you dot the same vector, the vector to itself, it will be the length squared, or it's just length times length. So number 3 is false, and thus A is the answer. Be number 1 and number 2 are true. Let's move on to number 4 here. We're given the length of vector A and the vector itself for vector B and the angle between. Find a cross product. So we can use the identity that cross product equals to the lengths of the vectors times the sine of angle in between. And thus, since we know the length of vector A here, we can just plug it in 4. To calculate for the length of vector B, plug it in, and calculate for the sine of the angle in between, and then we can get the answer being 18. Moving on to number 5, a classic angle in between the curve question. So as always, I recommend graphing the functions out, and you'll get a clear picture. So the area we're looking for is here, highlighted in yellow, and we can see that the line of 2 minus x is actually above the whole time during this section. So we can put it on top, and then we can find the bounds by setting the two equations to each other. You can rearrange this being y equal to 2 minus x, and then you set them together, and then you can get the bounds of being x equal to -2 and x equal to 1, as shown here. So, and then to write out the integral, the bounds would be -2 to 1, and since the 2 minus x is on top, you can say 2 minus x minus the x squared dx, which is a here. Moving on to number 6, find the area of the curve between the functions. And as always, graphing it out would be the best. The downwards parabola and the absolute value function should be pretty obvious, as it just the negative part of the line would just snap back up above the x-axis, and the area, the total area, would actually be, hold up, what is happening? Would be actually here, but for the solution, notice the symmetry between the left half and the right half, so it only solved for this part, which is smart because solving for the absolute value function is actually a pairwise, I think that's what it's called. So above, when x is more than 0 or equal to more than 0, the equation equals to y equal to x. When x is, wait, that should be more than, when x is less than 0, the equation of the line is actually y equal to -x. So that's why you would need to write two integrals if you don't notice the symmetry, and do just 1/2 of the times 2. So that's the idea behind the symmetry and the 2 here. And then, well, since we know that it's starting on 0, and solving for that would just mean that you just let the two equations equal to each other, and you can get that x equal to 1 is one of the bounds. And then notice that the parabola of 2 minus x squared is actually on top, so it will become first, and then minus x being the bottom line. Then solving this integral, then just becomes, just integrate this, being 2x, and power rule here with the bounds, and should get, let's see, continue on, should be 2 and 1/3, which is 7/3. For number 7, we are told to use cylindrical shells to find a formula for the volume. So if it says find a formula, don't just find a formula and don't solve it. I done it once. It's wasted me like 2 minutes, or rather like more than that maybe. And we were given the functions of the parabola and a horizontal line, and that will give us the area around here. And the whole area is revolved around this line. So then, uh, cylindrical shells, since it's rotating uh, horizontally, the rotating actually is horizontal. That means using cylindrical shells will have to be dy, um, as the height would be this way, and the radius from the rotating axis will be this way. And and it's dy. And further explain, it's because so the idea of cylindrical shells is that you have shells that's kind of like uh, a cylinder in a way, of like, and it's infinitely thin. So in that sense, the rotating axis here should be the same as the height of that shell. And since the rotating axis is actually horizontal, that makes the height here horizontal. And then we can set up the equation. Since it's dy, you actually need to solve the equation for y, and uh, or you can just look at this graph in the sense that you can tell that y equal to 0 is 1 point, and uh, y equal to 1 is 1 with the bounds. So that's why the bounds are 0 to 1, and um, then it will be 2 pi per the cylindrical shell method, and the radius would be 3 minus y, since it's the distance away from the axis, um, as the axis 3, and then the y here would be where the function's at, minus the the axis. And the height, as we notice, you can turn your head 90 degrees towards counterclockwise, and then you can see that the height starts with this equation. You can separate the parabola into two halves, and then the bottom half will actually be this equation, and that's why it's marked x equal to negative square root of y, and x equal to positive square root of y. And that's why the height difference would be the top equation of square root of y minus the negative of root y. And to further solve this, simplify rather this equation, let's see, then it will be, so this part would be root y plus root y, which equals 2 root y. And then the 2 can go out to the 2 pi, making 4 pi in the front. And the bounds, the radius, and then root y is the same as y to the half power, and thus comes the answer choice C. So when they suggest something like this, and you got an initial equation like this, always try to simplify, see if you can make this equation more like one of these, and then uh, one way to know is that by looking at, let's say, dy dx. If you know that it has to be dy, you can just instantly uh, just cross out D and E, and then it just comes to like this one is not the right bounds and not the right radius, and you can get the equation looking something like this. Then you can tell if it's 2 pi or 4 pi. Moving on to question 8. This is a physics question rather, and so the force, the spring force will be F equal to kx, being the force is F, k is the spring constant, x is the stretch. It's the length longer than its natural length. So here, plug in 12 needed for 0.1 of stretch, and you get spring constant of 120. It's pretty big, and it's Newton per meter. Sometimes the units are important since you can tell if your answer is right by the units. Um, and work, uh, the work done actually can be calculated since it's from natural position. You can just calculate it by just the change in energy, and the energy um, would be the energy at that state minus the original energy state. But since it's the natural length, so the original energy is actually 0, so you could just ignore it. So the spring energy is just half kx squared in the stretch, and then it would be 1/2 times 120 Newton per meter times 0.1 meters squared, and you should get that's 60 and 0.6 Newton meter. And of course, you can also do it this way, since work is the integral of force over distance. And then you can just, the distance is x, so just dx, the work, the force, and natural length is 0, and it will be 0.1. You should get the same answer. Let's move on to 9. The average value of the function. So 9, the average value of the function, if you don't know what this is, don't worry about it. If you didn't learn it, that's a pretty old thing. I don't think Calc 2 actually teaches this anymore. But if you want to know, it's just 1 over the bounds, and just integrate that function. And it's a simple by parts, and it's just this thing in front calculates the average value. For number 10, we have a trig integral, in a sense. So see that tangent and secant is a good combo. Tangent and secant are both odd powers, so we can separate out one of the tangent squares, and as seen here and here. So secant tangent would actually be the derivative of secant squared. I mean secant x, and taking the derivative of that, you get secant tangent. So you can use solve for this. U equal to secant x, and you will get du equal to secant tangent dx. Then the original integral then becomes 0 to pi over 4 u squared, and then by the bounds is not that actually, but this is du. You can integrate this, then it will be 1/3 u squared with the bounds. I'm not calculating right now, but when we sub u back in, then it would be 1/3 secant to third x. Then you can have the original bounds. Remember, when you use sub, you can either solve for the bounds. You can put the bounds, the bounds in for on here, and you can solve for u and just put those in as the bounds for u, and you can just solve it there, or you can sub u back, sub x back in for u and use the original x bounds. And so going from here, just plug pi over 4 and 0 in for secant x, and you could get, let's see, that would be 2 root 2 over 3 minus 1/3, which should give you e. So for values to, when you plug in these values, it's pretty important to know the unit circle to be able to um, like just know what the secant of pi over 4. Actually, pi over 4 is pretty easy since it's always root 2 over 2, root 2 over 2, or the cosine of pi over 4 would be root 2 over 2, and then the secant would just be root 2. Yeah, that's right. All right, let's move on. 11 here. Rotating between the functions and this one, since it's rotating about the y-axis, I would actually do cylindrical shells for this, but the equation uses disk and washer method, so it would actually involve dy. I usually just stick with dx whenever it doesn't specify the method of use, so that's why I use cylindrical shells when it's rotating about the y-axis. But let's just explain the solution. I will go on to the blank page and do cylindrical shells. So if we rotate around the y-axis, then the equation above would be the line of x equal to y plus 1. Now, seen here, that would be the radius put in, and pi radius squared minus pi radius squared um, of the lower equation, and it's just simplify into an integral and plugging values in, and of course solving the bounds would just mean plug uh, y equal to 1 equal to the bottom equation of y squared equal to 1, and you get 0 and 1. So alright, let's see. Question 11, cylindrical shells. Here, draw the same graph, the line into the parabola here. Is that right? No. Yeah, that's not the right graph. X minus 1. So when x equal to 0, it will equal to nothing. Then it should be here. So when you're graphing a parabola that you don't know what it looks like, you can always plug in 0 for y or 0 for x, get a general idea, and knowing how parabolas behave, you can result in a graph like this. And then the area would be the area rotating about the y-axis here. So using cylindrical shells, we can say the volume will equal to 2 pi. The bounds, I actually need to solve for that. Root x to y equal to x minus 1. That would be x. Oh, that doesn't equal to x minus 1 equal to x minus 1 squared, which is x squared minus 2x plus 1, and then move all the stuff to one side. Then we have x squared minus 3x plus 2, and then factor, that should be a squared. We get x minus 2 and x minus 1. And thus the bounds are 1 and 2. And let's erase that. Knowing that the bounds are 1 and 2, proceed. And the radius will be the distance from the axis. And so it would be just x in this case. Since the axis would rotate about 0, so just x minus 0, and the height would be the top equation of root x minus 1 here minus the bottom equation of x minus 1 dx. So if you're doing dx, make sure all your variables are x until you get to calc 3 and you have double integrals, triple integrals. But for now, a good way to know that if you write the equation right is, do you have the same variable as the variable you had taken the integral of. And the height here looks good. So let's see. And then it will be like something like this. X squared minus x. It's actually pretty. Yeah, this is not easily solvable. Can I make something like this? It'll be plus this. Yeah, and it will be u to 2/3 and plus root u. Yeah, this is definitely solvable, but it might be a little bit harder than the disk method. And you don't really know how one is gonna work better than the other one until you actually solve it. But in this case, it seems like the disk method actually might work better, since this might actually need u sub and into some complicated stuff. But if you see something like this, I think you can definitely solve this with u sub x minus 1 equal to u, then x will actually equal to u plus 1, and then you can separate this and integrate like you integrate u here, and then you can probably get this. But this is how you would solve it with cylindrical shells. Well, onto the last bit here, and for this, you just have to see that this is a by parts question. And it's actually one of those cycling by parts since it has cosine in. So when you take that as the derivative or the v part, and then you just cycle back x equals such. And for Lyatie, you can see that you can or just use the e for u, and then you can take the derivative of u, and then you list out u, du, v, and dv, and you will have uv minus v du, and since there's a negative here, you can put it in front, and it would be plus this here, and that's just v times du. And notice that it's really similar to the original, so you can byparse that again using e to the negative x as u, and the rest as v here, and as dv, and then you can get v and du, and do v du again as shown here, and then negative negative udv, and then this time the negative and negative will cancel out, and then if you rearrange this, you can get here. Let me circle that with the yellow, and notice how that's the same thing as the original. So you can say the original would equal to something like I, as it's said, it's using here, or it can be anything x, not x, but like a or p, whatever. Then I would equal to, since you're still solving for this, I is on the other side, so I is on the left side, and this part will be here, and minus 16i, since it's the same as the left side. So in this case, you're just seeing I as a independent variable, and so we move the 16i over, it would be 17i equal to this thing. And thus, you can divide 17 over, so I would equal to 4 sine x over 4 minus 16 cosine x over 4 over 17 e to the x plus c. Always remember plus c when you do integrals. So that's why that's b. And that will be all for this exam. Thanks for watching.